Hey, welcome back. I want to give it up to the one person, at least, okay, that had to take at least one extra chance on the Mastery Challenge last section in order to get it because they thought, oh, well, I see the short way, Mr. Gall. This is how it is, and didn't go through the work. All right. If you were that person, go ahead and give yourself a big pat on the back. You already have a sneak peek as to Section 9.2, Properties of Exponents. And today we're going to be simplifying expression using those different properties. And let's go ahead and look at just a review from yesterday. But when we have 2 to the third times 2 to the fifth, I think we had this problem. Okay. What that ends up being is 2 times 2 times 2. Okay. And then we multiply that by 5 more. Okay. And so what we get is we get 3 there, 5 there. 3 plus 5 is 8. So we get 2 to the 8th power. All right. And what most people saw is that, well, 8, you get 8 from these two exponents here. Okay. And if you saw that, congratulations. You know, that does take some intuition, especially if you hadn't been taught it before. But, you know, last section I asked you not to take that shortcut. This one, though, you're going to get to shortcut your way right on through. Okay. So let's look at the definition of the product rule. Okay. If I have a problem that looks like a to the m power, okay, we're going to be using a lot of the same letters today. And I multiply that by a to the n power. Okay, getting real colorful on you here. Our shortcut is that we're going to get a to the m plus n power. Okay, a to the m plus n power. Now, if you notice, the one thing that's the same here, the a's. Okay, and that's crucial that those two are the same base. Okay, and I'm going to put this in big letters here. We need the same bases. Okay, the number that is being raised to a power is called the base. So we need the same bases in order for these problems to work. Let's go ahead and use that idea on a couple of these. Okay, so here I have 5 to the third times 5 to the sixth. Okay, product rule tells me that I can rewrite that as 5 to the 3 plus 6, which simplifies to 5 to the ninth. Okay, that's a lot easier than writing out 3 5s and then 6 5s and counting them up. I get it. Okay, now we get to use that. Okay, we can never use things before we know them. Here, I have x squared, x cubed, and x to the fourth, all multiplied together. So what that means is x to the 2 plus 3 plus 4. They're all x's down there, so it works. Okay, what's 2 plus 3? Well, that's 5. Plus 4, hey, 9 again. So x to the ninth. Okay, but the key there is that all these were x's. Okay, if one of those was a y or a number even, okay, then it wouldn't work to add them all together. You could add 2 with the same base, but not with that other base. Okay, here we have a little bit different problem. Okay, in fact, what I want you to do is go and pause the video and try this one. Okay, welcome back. Hopefully you had a chance to get that done. And hopefully you did it. The key here is that 3 is not being raised to that second power. Okay, 3 is out in front. So we're going to treat that as if it's out in front. I'm going to look at this as 3 times b squared times 7 times b to the fourth. And all I'm going to do is rearrange it to where it's 3 times 7 times b squared times b to the fourth. Okay? From now on, you can do that without writing these two steps. All right? We just know that when we're dealing with multiplication, it's what we call commutative, and we can just switch the order of these two. Okay, you do it all the time, whether you think about it or not, because somebody told you way back when, okay, when you started multiplying, that you could do that. So what's 3 times 7? Well, Mr. Gall, that's 21. There we go. And then we're going to be dealing with this product rule right here. Okay, this is where today's stuff comes into play. So b to the second times b to the fourth is b to the, wow, 2 plus 4. Having a hard time talking. So that's 21. 2 plus 4 is 6. All right. It might have been easier to just write that out and do it, but hey, we like to have a little fun here. And we like to make things shorter whenever we can. Okay, here I'm just going to take the preliminary step. I'm going to get all the numbers out in front and all the A's at the end. Okay, so we're going to go 2 times 3 times 6 times a to the third times a to the fifth times a squared. Okay, now I'm going to use my product rule. First, I'm going to go ahead and multiply these together. 2 times 3 is 6. 6 times 6 is 36. And now I'm going to have a to the 3 plus 5 plus 2. 3 plus 5 is 8, plus 2 is 10. There we go. We are rolling here. Let's go with this one here. We have 3 and an 8. I'm just going to simplify that right now. 3 times 8 is 24. Okay, I have x to the fourth and x squared. So x to the 4 plus 2. And then y to the 5 and 7. 5 plus 7. Okay, that can literally be your next step. Right? You don't have to rewrite, these steps up here. You don't even have to write this step here. Okay, you can just go straight here. So that's 24. 4 plus 2, that's 6. 5 plus 7, that's 12. I need this step. Okay, I really need that step right there. That shows me that you're using this product property up here. Okay, you can't skip that one, even though you're just adding. Trust me, I know that I could skip it, but if I was at this point in my career, I would be told that, I can't skip it. Do the work, show the work. Okay, that's showing your work. Okay, I even went through classes in college where right there you had to say, well, that's using the product rule. I'm not asking that you write that. Okay, you just need to show it. Here we go. Last one here. And we'll move on to something else. 12 and 12, that's 144. When you multiply those. Okay, a to the fourth and a to the eighth. That's a to the 4 plus 8. And then b to the 12th. And b to the 32nd. That's going to be our b to the 12 plus 32. Sorry about that. So that gives me 144. A to the 12th. Okay, because 4 plus 8 is 12. And 12 plus 32. It's going to be 44. Okay, and that's it for those problems. Okay, that's product rule, and that's pretty sweet. Okay, it shortens our work quite a bit. All right, let's get going here. Yesterday or last section, I guess, we would have written 2 times 2 times 2, and you can go and write this as well. We would have written this 2 times 2 times 2 5 times. Okay, I'm sure you're, wait, 1, 2, 3, 4, yeah, I need one more. I'm sure at this point yesterday, or last section, your hand was cramping up just like mine, okay, and you were getting tired, Mr. Gall, why do I got to write all this? I get the jump. Okay, how many 2's are there? Count them up, you're going to get 15. Okay, and how do I know that? Because it's 3 times 5. Okay, 3 times 5 is 15. So, another question. Why don't we just skip right there? Well, we can. That's what we're doing today. Okay, power rule. If I have A, and I'm going to switch colors here again, A to the M, and I'm going to raise that. Okay, the original problem raises that quantity to the N power. All right, and then we would get, it's going to be equal to A to the M times N power. All right, and that's going to be our answer there. So we're going to multiply those M and N's together to give us our answer. All right, let's go ahead and look at or see what that looks like. Okay, with actual numbers down here. So we have 4 to the 12th to the 5th. What I need to write is that is 4 to the 12 times 5. Okay, and trust me, you don't want to write that one out by hand, because that ends up being 12 times 5. That is 60. So you would have 60 4s written down. That's a lot. Okay, we don't want to write that many 4s. That's crazy talk. All right, let's move on here. So I'm going to have 12 to the 3rd raised to the 12th. So that's going to be 12 to the 3 times 12. Okay, and 3 times 12 is 36. So that's going to be 12 to the 36th power. Okay, I don't want to write 12 36 times. I don't want you to have to either. All right, this one looks weird. Okay, it looks weird because there's a -7. That's being raised to a power, and we put negatives in parentheses. But then we need another set of parentheses. That's these square brackets. Okay, it looks tough, but it's really not. All we really have here is a -7 to the 15 times 5. Okay, to the 15 times 5. And so what that's going to give us, if you got to use a calculator, feel free, but that's a -7 to the 75th power. Okay, sorry that got a little sloppy there. I was getting distracted. Maya wanted to play. Okay, I want you to go ahead and pause the video. Try these next 3. Okay, welcome back. Let's go and see what we have here. All right, I have x to the 14th raised to the 14th. So that's just 14 times 14. Okay, 14 times 14 is 196. Okay, so I'm going to have x to the 196th power. All right, I know I asked you to do these, and they are a little bit difficult. Okay, and you might have to break out your eraser right now. But the tricky part on these next 2 is that whenever we deal with parentheses and exponents outside, we need to raise everything in the parentheses to the 4th power. Okay, if you got that, that's really awesome, and I'm really proud of you. Okay, so what that means is I'm going to write a preliminary step here. I'm going to have 10 raised to the 4th power, and I'm going to have x to the 6th raised to the 4th power. So I'm going to rewrite that in parentheses. Okay, maybe you didn't write this step. If not, that's okay. It's not wrong. So I have -10 to the 4th. I can't simplify that anymore. And then I have x to the 6th times 4. All right, so we get -10 to the 4th. 6 times 4 is 24. So x to the 24th. Okay. Same thing here. I want to distribute that 3 into everything. So I'm going to have 1/4 to the 3rd. X squared to the 3rd, which turns into x to the 2 times 3. And then y raised to the 3rd. So I have 1/4 to the 3rd. Remember, I'm writing those in parentheses so that I know it's that fraction raised to the 3rd power. And that'll be x to the 6th, y to the 3rd. And that's my final answer. All right, let's look at the last or the last page here. And let's look at, okay, we had this problem yesterday. And we had 2 times 2 times 2 times 2 times 2 over 2 times 2 times 2. All right? And then we canceled things out. So canceling things out there. All right? And we ended up with, well, there's only 2 2's left. So that would be 2 squared. All right? Now, what we're going to look at here is how do I get an exponent of 2 by, go on. How do I get an exponent of 2 when I have a fifth and a third? Well, 5 minus 3 is 2. So what that means is that if I have, again, I need same bases, a divided by a, and they're going to be 2 different powers. Let's say we have an m there and an n there. That's going to equal a to the m minus n. Okay, a lot of work switching colors here, but you know, I'm doing it for you guys so that everything's hopefully making a little bit of sense. Okay, let's go ahead and look at this in terms of actual problems that we're going to see. Okay, so here I have 2 to the 11th and 2 to the 5th. That's going to be the same as 2 to the 11 minus 5. Okay, 2 to the 11 minus 5. Well, that seems pretty easy. 11 minus 5 is 6. So 2 to the 6th. Next one. I have negative 4 to the 7th, negative 4 to the 3rd. Notice, same basis. That's very important. That's going to give me negative 4 to the 7 minus 3. Okay. So 7 minus 3 is 4. So I have negative 4 to the 4th. Okay, we got to speed things up here. Let's look here. Actually, what I want you to do, I'm going to go ahead and let you do this one. Okay, pause the video, get this one done. Okay, welcome back. Let's go and look at what we have. So hopefully you got this one done pretty easy. It's just like the problem up above with 2's. Okay, but now we're dealing with x's. All right. 5 minus 3, that's going to give us x to the 2nd. Okay. All right, let's look at what we have going on here. There's a little bit more stuff going on. I have numbers involved now. Okay, all that means 3 over 12. 3 over 12 is 1/4. I'm just putting numbers in front. I'm going to simplify whatever fraction that gives me. And then I have y to the 11th and y to the 3rd. So that's going to be y to the 11 minus 3. So I'll have 1/4. 11 minus 3 is 8. Okay. So that's my answer. There's nothing more I can do there. All right, let's look at this one. Deal with the numbers first. Treat numbers like they're numbers. 49 over 7. That's just going to give me 7. I have multiple variables going here. I'm going to combine the ones with like bases. So I have x to the 7 minus 6 and y to the 12 minus 5. Okay, keep that 7 out in front. 7 minus 6, that's 1. I don't have to write an exponent of 1. Make your life a little bit easier. Okay, 12 minus 5, that's going to be y to the 7th. I want you to go ahead and pause the video. Try this last one out. Okay, welcome back. Hopefully you got a chance to get that done. 2 over 6 is 1/3. X to the 9 minus 1. Remember, if there's nothing there, it's a 1. Okay, so x to the 9 minus 1. Y to the 4 minus 2. And z to the 5 minus 4. So that leaves us with x to the 8th, y squared, z. Or z to the 1st, either way. All right, down here it says PEMDAS. Okay, PEMDAS cures all things. Okay, here's the deal. Here's what we look at. When I have, and the reason I say this is because everything's involved here. When I have exponents, okay, and what that means is an exponent raised to an exponent, I'm going to multiply those exponents. Okay? Make sure you circle the same things that I do. The reason we write PEMDAS this way is because in the normal world, when you're just dealing with an expression, you do parentheses, exponents, multiplication and division, okay, and then addition and subtraction. But it also helps us out because when I multiply, when I did product rule, what did I do to the exponents? I added them, right? So I'm going to add those exponents. When I multiply, I add. And then the last one, when I divided right up here, what did I do to those exponents? It's right there. I subtracted. Okay? So PEMDAS cures all things. Okay? And then we kind of deal with when I have parentheses, I raise everything to a power. Okay? And that's what we're looking at in these two problems. With this 3 outside, I want to raise that 2 and that 3 to the third power. So 2 to the third over 3 to the third. There's nothing else I could do there except to figure out what those are. 2 times 2 times 2, that's 8. 3 times 3 times 3, that's 27. Okay? And that's a simpler way, I guess, but I do like exponents also. In this one, okay, why don't you go ahead and pause it and try it. Okay, welcome back. Hopefully you realize that that 4 has to be almost distributed to everything. So I have 2 to the 4th, x to the 4th, and then y squared to the 4th. Okay, when I have y squared to the 4th, I need to multiply those exponents. So 2 to the 4th, x to the 4th, 2 times 4, that means y to the 8th. Okay. Let me get these last two problems done and we'll be done with the day. Again, distribute that 3 into everything. Okay? So that 3's got to go to everything. We're going to have 2 to the 3rd, a to the 3rd times 3. So that's going to give me a to the 9th. B to the 4th times 3, that's b to the 12th. And then I'm just going to rewrite what I have here. I have 4a, b to the 5th. Okay. And on the bottom, 64, a to the 5th, b to the 3rd. Okay. Let's go ahead and combine these ones here. Okay, it says bring the pain because these problems are a little bit difficult. So 2 to the 3rd is 8. 8 times 4 is 32. Let's combine those numbers first. A to the 9th and a to the 1st. Add those together. We get a to the 10th. B to the 12th. B to the 5th. Add those together. We get b to the 17th. All over 64. A to the 5th. B cubed. Can't combine those. Okay. Sorry, I'm kind of rushing through this. Maya's freaking out. I think she has to leave. She has to go out. Okay, but let's go ahead and look at this. I will have. Let's deal with the numbers. That's just going to be 1/2. All right. 10 minus 5. That's a to the 5th. 17 minus 3. That'll be b to the 14th. Go ahead and pause the video. Try the last one. Okay, welcome back. Let's go ahead and look at this. So this 2 has to go to everything. That means everything up top and everything down on the bottom. Okay, I kind of missed that, but we'll go there and there. But another way to do that is to simplify what's on top and bottom and then raise that to the second power. I'm going to do that instead because that just looks confusing and my head hurts. Okay, let's simplify what's on top. -2 and 3. It'll be a -6. I'm going to put a big set of parentheses around all this. M squared and m to the 9th. 2 plus 9 is 11. n cubed and n. 3 plus 1 is 4. And then on the bottom here, I just have to rewrite that. M to the 7th, n squared. That's still all raised to the second power. Okay, I could distribute that second power now if I wanted to, but I don't. I'm on the right track here. I want to simplify that even more. Negative 6 divided by negative 3 is negative 2. M to the 11th, m to the 7th. How many are left over? Subtract those. 11 minus 7 is 4. And n to the 4th, n squared. 4 minus 2 is 2. Now I want to take that 2, and now I just want to put it into these ones. So that's a lot easier. Okay? So I'm just distributing distributing the same thing to a smaller set of things. So I have negative 2 squared. M to the 4 times 2 is 8. And n to the 2 times 2 is 4. That's my answer. That's pretty easy. Okay. If I write it the other way, it looks really ugly and it gets very, very confusing. So simplify what's in parentheses first and then distribute that outer exponent. Okay. Good luck. Make sure you get the practice and application problems done, and good luck on the Mastery Challenge. See you guys later. Alright, so we're looking at the rules of the gym. So when we're going to work out, we know number 4, probably be careful with box jumps. Number 3, keep your balance. Balance is very important, and you want to make sure that you have both feet underneath you and hopefully in a somewhat vertical position.
Tryk til, tryk! Do it for YouTube. 21, 22, 23, 24, 20.